Good afternoon, everybody. Reed here. Let me just wait a few minutes to let a few more people come in. And today we're going to have our discussion on acetylcholine and how very important the acetylcholine receptor and the acetylcholine networks are. They're very important. And in fact, as I mature and grow as a clinician, I'm starting to understand how important the role acetylcholine plays in how the symptoms are manifested, right? So acetylcholine is important for a lot of very important things in the body, such as things like memory, things like arousal, things like that. And we'll do a deep dive into the acetylcholine muscarinic network, and then hopefully I can give you an idea of how this network operates and how useful it'll be for you as a clinician. So let's see. Okay, here. So I'm on the free version of Grok here. You can use any search engine. Here, explain the acetylcholine muscarinic network. Okay. The acetylcholine muscarinic network refers to the system of neural and physiological processes involving acetylcholine, which is the neurotransmitter, and its action on the muscarinic acetylcholinergic receptors. Look at this. Muscarinic, right? Acetylcholinergic, right? Receptors, right? Muscarinic acetylcholinergic receptors, right? This network plays a critical role in the central nervous system, the peripheral nervous system, and various psychological functioning, right? And see, this is why we want to know more about the acetylcholine for its impact on the central nervous system, and also, look, various psychological functioning, well-being, memory, attention and concentration, things like that. Those symptoms sort of give you a reflection of how well the central nervous system is operating, but it doesn't show you actually where the dysfunction is coming from. So when we talk about the CNS, we talk about the specific targets in the tissue. And we talk about the various psychological function, meaning that the symptoms you have, the diminishing swarm, lack of awareness of the environment, things like that. Those are the psychological issues it creates. Below is a comprehensive explanation of acetylcholine muscarinic networks, components, mechanisms, functions, and significance. Before I get to this, let me tell you why this is so important. Let me look. Okay, here. Explain. So, Aricept is a medication that targets acetylcholine. It inhibits acetylcholinesterase, and that's the enzyme that breaks down acetylcholine. So that's the strategy, all right? Now, why would I use Aricept? Let me give you an example. Whenever you have patients with head injuries, okay? You can get damage from multiple locations with the head injury, right? And this damage can result in just diminishing swarm, lack of awareness of environment, fatigue, tired, there's difficulty thinking, and that's a result of the damage. And so that diminishing swarm is likely attributed to deficits in acetylcholine in certain parts of the brain, right? So somehow in the diffuse traumatic brain injury and other head injuries and things like that, the inflammation and things can lead to changes that result in a diminished amount of acetylcholine in certain very important parts of the nervous system. And so, of course, we're going to need to shut off the enzyme that degrades acetylcholine. Once we shut down the enzyme that degrades acetylcholine, then the amount of acetylcholine builds up in the synaptic cleft, and hopefully it's enough to start improving transmission along the acetylcholine muscarinic network. If we get more hyperactivity in that work, then we get more arousal. We get better attention, we get better concentration, we get improved memory. So in patients with diffuse traumatic brain injuries, you want to look at the acetylcholine muscarinic network, and if they're having difficulty with attention and concentration, impulse control, things like that, you may want to consider Aricept to increase that acetylcholine muscarinic network activity. But let me just show you a few studies that support the use of Aricept and acetylcholinesterase inhibitors in diffuse traumatic brain injuries and other type of brain disorders, including Alzheimer's dementia, right? So Aricept is also known as donepezil, is a medication primarily approved for treating symptoms of Alzheimer's disease, where it works as a cholinesterase inhibitor to increase levels of acetylcholine, a neurotransmitter involved in memory, learning, and other cognitive functioning, right? In the context of traumatic brain injury, Aricept is sometimes used off-label to address persistent cognitive defects, such as sometimes used. I think it should be used more. And it's not really, Aricept is not really associated with a lot of different side effects, such as memory, attention problems, reduced processing speed, and this can occur due to damage to the cholinergic fibers in the brain. Damage to the cholinergic fibers, right? That damage could have been caused directly by inflammation, right? Or direct damage, such as a traumatic brain injury, right? This off-label application aims to enhance neurocognitive recovery by boosting acetylcholine availability, right? Potentially improving brain metabolism and supporting functions like arousal, motivation, and REM sleep, right? On the studies on Aricept and TBI, including case reports, open label trials, and small randomized controlled trials, have shown mixed but generally promising results. I've had a lot of, but you have to use it specifically on those patients, but I've had a lot of results for this. For instance, it's been associated with improvement in short-term memory, sustained attention, and overall cognitive function in patients with a chronic TBI. That's true. That's true. Here, there's a PubMed citation. One pilot study found element enhancements in visual memory after 4 weeks of treatment. Another small scale study reported significant gains in processing speed, learning, and attention. So this is in the case of a diffuse traumatic brain, of a traumatic brain injury. Let me see. Okay, I'm saying explain Aricept, the use in Alzheimer's dementia, because remember, with Alzheimer's dementia, you get loss of those cholinergic neurons, right? And so we want to use donepezil or Aricept to shut off that cholinesterase inhibitor and stop the degradation of acetylcholine, so we can increase the constant titer in the synaptic cleft and therefore increase the network activity. So here in Alzheimer's dementia, let me just go through this mechanism again. Aricept is a cholinesterase inhibitor widely used to manage symptoms of Alzheimer's dementia, a progressive neurodegenerative disorder characterized by cognitive decline, memory loss, and impaired daily function. So the symptoms of Aricept really focus on those memory problems, and then you start to see them over time have a diminished awareness or diminished alertness, things like that. So this is why we use Aricept in this case. And just look at the what we use for. Again, inhibits acetylcholinesterase, the enzyme that breaks down acetylcholine in the synaptic cleft, thereby enhancing cholinergic transmission in the brain. They must have been listening to me, because it said the same thing I said. This temporarily improves communication between neurons, right? Helping to alleviate cognitive symptoms. of Alzheimer's, particularly in the mild to moderate stage. You see this? You got it? Acetylcholinesterase muscarinic network hypoactivity leads to the symptoms consistent with Alzheimer's dementia, right? Patients with schizophrenia typically may or or substance abuse issues may have the diminished cognitive awareness and things like that, difficulty thinking, difficulty with their memory. Yeah. So even in the case of schizophrenia and bipolar disorder, you have to start looking at those acetylcholine networks to see what's happening there. And so Amenda can go a long way in these cases. Okay. And we want to use these, look, improve cognitive functioning, right? Look, memory again, look, attention again, concentration again, and what? Visual spatial. I'm sure your visual spatial will improve if your memory, attention, and concentration improves, right? Okay. Slow symptom progressions. While not cure, it can delay worsening cognitive and function decline, although patients maintain independence longer. Enhance daily function. Patients may show better performance in activities of daily living, such as managing tasks. So, diffuse traumatic brain injuries, damage the acetylcholinesterase inhibitor, the cholinesterase network, boom, hypoactivity. Alzheimer's disease, same process, mechanism different. Traumatic brain injury due to trauma. Alzheimer's due to the buildup of those like inclusion bodies, right? And they kill the cell. Let me see. Let me look at, we're going to go to a different neurotransmitter system. Let's say Parkinson's dementia is primarily dopamine in the basal ganglia. But let me see the impact, this relationship between that acetylcholinesterase muscarinic network and Alzheimer's in Parkinson's dementia. Okay, explain the use in Parkinson's dementia. Okay. Because remember, the movement disorders, the sort of the mass spaces, the stiffness and things like that, the shuffling gait and the postural instability and things like that. But I'm sure the cognitive functioning is diminished also. So even in patients with Parkinson's dementia, where the disease process involves a different neurotransmitter, particularly dopamine, I think we still have to consider acetylcholine, because you still have the diminished cognitive issues seen in Parkinson's dementia. And how are you going to address those? So here, explain Aricept use in Parkinson's dementia. Aricept is a cholinesterase inhibitor. We got that. But use off-label in cognitive symptoms in dementia, a condition where individuals with Parkinson's disease develop dementia characterized by memory impairment, executive dysfunction, and difficulties with attention and visual spatial. Right? Mechanism still works by inhibiting cholinesterase inhibitors. The utility still cognitive benefits. Okay. Functional behavior and symptom stabilization. Okay. So, of course, it's off-label, but if your patient comes in with those noticeable cognitive deficits, you're still going to have to do something to help them with attention and concentration. And this is one of the reasons why I use it. Let me see. Let's see, what else can I look for? This, I think that's it. So now you would see the indications why we would want to use target this acetylcholine muscarinic network. Now let's look at the actual network and let's see how it functions. Okay. So here, overview of acetylcholine and muscarinic receptors. Okay, so they take these two at the same time. So they take the acetylcholine, they address acetylcholine and muscarinic receptors at the same time. Okay. Acetylcholine is a neurotransmitter widely used in both the central nervous system and peripheral nervous system. All right. It interacts with two main types of receptors. Okay. The nicotinic receptors and the muscarinic receptors. These are ionotropic, right? Metabotropic, right? These are ligand ion channels, right? These are G proteins. And and then look, slower mediating modulatory effect. Now, you see that strategy also where each fiber system, whether or not it was the mesocortical pathway or was a mesolimbic pathway, or remember the pathways in the basal ganglia, it was always a combination of receptors that operate ion gate, ligand gate ion channels, and then another population of receptors that actually modulate the G protein receptors, right? And here we see the same pattern on the acetylcholine muscarinic sort of network. You see the receptors that target the gates, and then the receptors that target the G proteins. Here's why that's important. The gates are responsible for that signal transduction, propagation of the action potential, right? And the metabolite, that's the ionotropic, right? That's the fast acting to get a response right away. And it also sets off that action potential to send that signal down to the terminal, the other end of that neuron, to tell them to release the gates, release everything that's been stored up. So that's one way that receptor gets its products exited out of the cell by the signals that goes along for the action potentials. The other group of receptors, the muscarinic receptors, metabotropic receptors, are the G proteins. Now, remember, the G proteins is the signal transduction cascade when the molecule target attaches to the ligand on the G proteins, which are usually huge 7-unit phospholipid bibrain layers spanning molecules that convert their 3D configuration, which results in the 2 subunits breaking off and they become active and start creating things, right? So this muscarinic receptor is eventually going to send a signal to the cell body to create a product that it's going to eventually export. And to create that product, it takes a while. It takes some time to create that product. The action potential is long gone by the time the product actually exits the cell. And it can produce, so these G proteins can produce products that secrete things from the cell, in a very rapid filler, or activate other type of channels and receptors. This network has those 2 type of properties: the collections of gates and then the collections of products that it would like to create. The muscarinic network specifically involves the muscarinic receptors, which are named after their sensitivity to muscarine, a product derived from certain mushrooms. Okay. These receptors are found in various tissues, including the heart, brain, smooth muscle glands, and autonomic ganglia. Great. Number 2, the types of muscarinic receptors. Okay. Mechanism of the muscarinic network. Let me see. Function of the muscarinic network. Neuroanatomy. Okay. I don't think I'm going to go through the neuroanatomy. The pharmacological relevance. I don't think I'll go through that. Modulation. The muscarinic network is tightly regulated. Acetylcholinesterase breaks down acetylcholine in the synaptic cleft, terminating the signal. Feedback mechanisms from the muscarinic 2 and 4 receptors on the presynaptic cells act as autoreceptors, inhibiting acetylcholine release to prevent overstimulation. Wow. Okay. And then crosstalk. Muscarinic receptors interact with other neurotransmitter systems to fine-tune neuronal activity. That makes sense, right? So in order for regulation, if we want to increase the activity of the muscarinic network, then we release acetylcholinesterase. It breaks down acetylcholine in the synaptic cleft, right? No, it causes. Let me move over here. I'm getting confused there. So let me go back up here. Okay. So let's look at the types of muscarinic receptors. There are 5 types of muscarinic receptors, 1 through 5, each with distinct distribution, signal mechanisms, and functions. They are classified based on their coupling to specific G proteins. Wow. Okay. So 2 types. And then it's always like that. Remember, like the types of dopamine receptors and everything, and then remember the type of like the serotonin receptors and things like that. And inside that family of receptors, there are some that activate things, and then there's those that deactivate things. There's another pattern you'll see here with every neurotransmitter is that they're divided into activators, modulators, or inhibitors, and you see the same thing here. And sometimes all the details like M1, 2, 3, 4, it can be overbearing, but to remember, but just understand that that structure is there. The ones that activate the receptors and the one that, and they're all clustered together on the network. 135 GQ coupled. These receptors activate this G protein pathway. It increases intracellular calcium and it activates protein kinase C. They are generally excitatory, right? Now, M24 are these couple receptors. The receptors inhibit adenylate cyclase, right, reducing cyclic AMP levels, and can modulate ion channels, particularly calcium channels. They are inhibitory. So the two type of muscarinic receptors. Okay, so let's see where they're found. Okay, so there are two of these. Let me just see where these are found first. 2 and 4. 2 and 4 found in the heart, the slow heart rate, slowing the heart rate, I can imagine. CNS, small muscles, highly expressed in the autonomic system. And 4, okay, so it's found in the heart, and 4 primarily in the CNS, involved in modulating dopamine release and motor control. So wow, so this is where the muscarinic network starts to influence this dopamine network. Remember? So yeah, so I think that's, we see some of those improvements too. Remember, in some of those hypodopaminergic states, like Parkinson's dementia, we also see them get better when we give them Aricept. And I guess here the Aricept results in release of more dopamine. I guess the Aricept indirectly can improve the dopamine release. I guess that's the mechanism. It's very interesting to know that. Okay, here 1, 3, and 5, they activate the pathway and increase intracellular calcium, and this activates protein kinase C. So 1, 3, and 5, predominantly in the CMS. Okay, yeah, look, the cortex, hippocampus, and striatum, involved in cognitive functions such as memory and learning. Okay, so this is where the muscarinic activates it here. Very interesting. Found in the heart. Okay, we did that one. 3, present in smooth muscles in the GI tract, brachial tissue, glands, and the CNS is involved in smooth muscle contraction in glandular tissue. Remember, one of the side effects of Aricept is drooling, running, all things running, drooly mouth. You see salivary glands, runny nose, and things like that. And this is one of the side effects because it hits these M3 GI receptors involved in smooth muscle contraction. Okay, then we have M5. It's less abundant. It's found in the CNS, substantia nigra. Hey, an abundant vascular endothelium plays a role in dopamine regulation and vasodilation. I guess this M5 is very important, particularly substantia nigra. This is where Parkinson's dementia, this is where the pathology is at. So when using Aricept and that for the cognitive benefits, I can see this is why. It's through the M5 receptor. Okay, now let me see. Let's see. I don't want to go too far into some of this. Okay, I'm going to mechanism is okay. Okay, mechanism, yeah. Okay, the muscarinic network operates through the interactions of acetylcholine. Okay, great. All right, or the acetylcholine muscarinic network triggering intracellular signaling cascades. Okay, great. So these 1 through 5, okay, they activate the protein. Yep, and 2, 4, okay, they inhibit it. Okay, we got that. Okay, let me see. Functions of muscarinic network. The functions of the muscarinic network modulates a wide range of physiological processes in the CNS with cognitive and memory. Yep, motor control, receptors in the basal ganglia. Okay, Yeah, so muscarinic. Wow. So yeah, so they're located throughout the basal ganglia. I never really read too much about the acetylcholine receptors located in the basal ganglia, but I guess in motor control, this is very helpful. Influencing movement and coordination relevant to Parkinson's disease, right? Sleep and arousal. Muscarinic receptors regulate sleep, wakefulness, and REM sleep. Ah, via cholinergic neurons in the brainstem and forebrain. Okay, then we have the peripheral nervous system. Okay, and mediate parasympathetic effects. Okay, slow heart rate by inhibiting pacemaker cells and promote contraction of GI motility. Okay, I think that's it. I think that's half for now. Okay, and then let me see if I have any questions. Okay, and we're at 25 minutes now. I didn't want to go too far into this. Let's see. Let me have a question here. Hey, T-Jam, thanks for the question, buddy. Did Muhammad Ali suffer from a TBI? I think so. A diffuse traumatic brain injury, multiple ones. Was he on Aricept after his injury? I would think so. You know, Aricept's been around for several decades, and so I think they would have definitely had him on there. Okay, guys, I hope this is helpful for you guys. And so now when okay, let's say, hey, iHash guy. Thanks, iHash, for the question, buddy. Why do Alzheimer's patients often have a disrupted acetylcholine system? You know, because it has a predilection, the pathology has a predilection for cholinergic neurons. And so you get the death of cholinergic neurons in Alzheimer's dementia. And that's when you get all the cognitive problems that we just read about, right? Okay, so it's at 26 minutes. I'm gonna go ahead and call it for today. If you have any other questions for me, in the chat for me, I'll get to them if I can. Stuff, but other week, read out. You guys take care of yourself. Bye.